Hello, everyone, and welcome to this Robin webinar. My name is Adish Pule. I am part of the product management team here at Robin, and today's topic for the webinar is, are containers ready to run NoSQL databases? I'm really excited to talk to you guys today. We are doing some really interesting stuff at Robin, and during the course of this session, I'm very excited to share those details with you. So keep your questions coming. You should be able to ask your questions using the BrightTalk platform. And at the end of the session, I'll try to answer as many questions as I can. And if we have any leftover, I will, we'll follow up over email or we'll do a blog post. So let's get started. So if you have done a Google search on containers over the last 3 or 4 years, you would see terms like Docker. You would see microservices, stateless apps. So our session today is focused on how can we apply the same container technology to data-heavy apps like databases, big data, etc. So let's dive in. So true to the title of the webinar, we'll first start by discussing a few management challenges with NoSQL databases. Then we'll talk about why containers or why not containers, and are they sufficient by themselves, right? Do we need anything in addition to that? Then we'll spend a lot of time on the Robin solution itself, and we have interspersed a bunch of demos, so we just don't keep showing you slides. And then finally, we'll summarize and look at a few takeaways. All right, so the NoSQL class of databases is a very large space. You have document databases, you have key values, you have graph databases. So we wanted to restrict this webinar to a specific type, and so we chose Cassandra. In our future webinars, we'll take up other data applications, and we'll talk more about that. But for this session, we'll take Cassandra as our as a pivot point. So in terms of management challenges, right, there are 4 key challenges that we identified, or what we have heard from our customers. First is consolidation. Now, a common theme is that Cassandra clusters are built per use case or per SLA, which basically means that every team gets its own private Cassandra cluster. Well, that's great. I mean, in fact, it would have been great if we were using virtual machines, because then it's easy to deploy, it's easy to throw them away when you don't need them and all that stuff. But due to the hypervisors, most virtual machines today, like VMware, KVM, Xen, use hypervisors, and they have their own performance tags. They levy their own performance tags. And so large number of Cassandra clusters are deployed on bare metal. Unless you're deploying to cloud, in which case you have no choice. But if you're deploying on software or on-prem, you're using bare metal and you want to use all possible capacity for your clusters. Now, depending on the application, it is extremely difficult to get a constant load profile, which means there are multiple occasions where your servers are either idle or not fully utilized. And that's the first challenge. You have too many clusters and spread across too many physical servers, and the utilization on all of these due to varying load profiles is not 100%. So there is definitely scope for improvement. The second challenge is cluster lifecycle management. Now, Cassandra is not that hard to deploy, but one of the hardest things about, the Cassandra software is not hard to deploy. But one of the challenges is that you always want to build your cluster for a particular performance profile. So either you want it to be, either you want to run like write-intensive or read-intensive workloads, or a combination. And so oftentimes when you're designing your clusters, you either do paper exercises to figure out what kind of IOPS you can get out of your cluster or the configuration that you've chosen, or you would deploy 1 or 2 nodes and then you would run stress tests and figure out what kind of juice it can deliver. Um, so that's so that's fine, but with that approach, you could end up with two things. One is your estimations are just bang on target, which means the infrastructure that you purchased for your cluster is exactly what you needed. But more than likely, it's the other case where you have either under-provisioned or you have over-provisioned. And both those situations are bad because now you either have to go purchase additional infrastructure or you're stuck with idle capacity. The other aspect of your planning is planning for node failures. So failures are an inherent part of life. You just kind of wipe them. Now, Cassandra, again, is good at dealing with temporary failures, but if that temporary failure extends to a long period of time, or if you have permanent failures, then you have a problem. Essentially, if a node were to die in a cluster, you incur tax twice. The first time is when the node dies, the other nodes kind of have to take over the additional load. And second, even when you reintroduce that node or you recover that node, data has to be transferred. Data has to be rebalanced across all of them. And so the other nodes are again taxed because they are shipping, all the tokens and the data onto this new server. So so that's our second challenge. How can we make planning easier based on the performance profile that we have in mind? And how can we get rid of node failures? The third challenge is with data management. Now, unlike Oracle database, which is a fairly mature and old database, and it provides a great backup utility in RMAN or Recovery Manager, Cassandra is kind of limited in that space. It doesn't have an automatic backup, and backup management tool. So what Cassandra provides is snapshots and incremental backups, and essentially these are hard links. The problem with though is the snapshot capability is per node, and you have to run this manually. You may write, and so essentially what people do is they either use PSSH to coordinate the snapshot across all their nodes, or they use cron to schedule these, across all of them. Now, let's say you figure out a way of taking snapshots regularly. The second challenge, though, is that the snapshots are stored on the same disk as the data files. So the first snapshot is easy to take. It doesn't consume any space because it's just a hard link. But then compaction kicks in, and then you have older snapshots. And a combination of compactions and snapshots and incremental backups essentially will easily consume all of your storage. And then suddenly, the planning that you had done for your data files is messed up. So how can we solve, number one, the whole snapshot problem, the scheduling of snapshots and all of that? How can we make it more automated, more scheduled? And number two, how can we ensure that the backups that we take can be retained for any desired amount of time, and they don't eat up into the space that's required for the data files? So that's the third challenge here. And the last challenge is with scaling. Now, when I utter the word scale in context of Cassandra, everyone thinks of add node. Let's add a node. So I go from 3-node Cassandra to 4, 5, 6, and I gain additional capacity, I gain additional performance. But what about transient workloads? So scaling out is excellent when you have sustained workloads or you're onboarding new applications and you do want to permanently increase the size of or capacity of your cluster. But what about transient spikes? And I hear this a lot from some of the online retail customers. Like during holidays, like Thanksgiving, Labor Day, when you have all these sales going on, you see a peak in the utilization of your databases. But after that day, your clusters are heavily underutilized, and you're thinking, racking your brain to run something else and get the utilization up. It'll be great if, in addition to scale out, we had some solution for dealing with transient spikes. So as we said, during this, in the title of the webinar, we definitely want to use containers to solve this problem. But why so? And as I started my sessions by saying that if you've Googled containers, you will see that a lot of the web companies like Google, Netflix, and Spotify and Twitter essentially have successfully used containers for their stateless apps, for using microservice architecture, and etc. So clearly they have deployed it in production, and they have gained a lot of benefits out of it. So what's so great about containers, right? So containers, essentially, if you think of them, are sort of the next generation of virtualization technology. When you think containers, oftentimes you always think of Docker, and it's true for a large, for a lot of cases, majority of the cases, in fact, Docker has made containers really popular. They have made it very usable. I should say, it's not just hype, but they have made it really usable. And in future, you can imagine that containers might be the medium by which all software is shipped in the industry, right? Of course, we are not there today, but there's definitely signs that that may happen. So it's definitely the next generation virtualization technology. And similar to your classic virtual machines, each container can have its own IP address, it has its own file system, it has its own, has process isolation, has a user space, etc. So you sort of, if you just log into the container, you would feel like you're just logged into a VM or a server. But what's different about containers is that it uses features baked into the Linux kernel, which means no hypervisor cost, right? So you do not, depending on which virtualization vendor you use, you might be your hypervisor itself consumes anything between 10 to 40% resources, and that is huge. Whereas with containers, the performance that you get is almost similar to what you get on bare metal. And if you look at the graph on the right side of that slide, this is published by IBM Research, and you will see that containers, which are the bars in green, essentially almost match the bars in gray, which is bare metal. So they almost provide the same read-write performance, whereas VMs definitely take a hit there. So you get all the benefits of virtualization with containers, but you do not pay the performance penalty. So you get bare metal-like performance. So that is awesome. That sounds good. So can I just take containers and deploy Cassandra and other NoSQL databases and be done with it? Is that all I need? Well, clearly not. So if you look at just the numbers, right, the scale at which these are being deployed, so containers, you're definitely going to deploy about 10 to 100x more containers than you did virtual machines or the number of apps you deployed directly on bare metal. And that means that you need storage. You need a good partner in storage which can keep up with that pace, right? So you need millisecond response times in terms of start-stop. Each container can have multiple volumes, so you need support for multiple data volumes to be bound at boot time or coming, and these volumes could be SSD-based, hard drives, flash, NVMe, etc. So just taking traditional storage and deploying containers on top of it is not going to work. So you need a container-aware storage for it. Secondly, containers let you control CPU and memory. That's awesome, but what about I/O? Right? How do you control the read IOPS and write IOPS? And especially for an application like Cassandra, which is very sensitive, or any database for that matter, which is very IO sensitive, how can we control? So your storage needs to, again, deliver features where you can control or provide performance isolation for your IO as well. And the third thing is, if you look at the audience or the end users who are using databases, there are analysts and there are people who want to do data mining and run some kind of R scripts and things like that. So you want to give them enough control so that they can manage data by themselves. Right? So you need the ability to quickly provision, snapshot your data, clone if you need to, and then do time travel. And we'll discuss a lot of these going forward. All right, so what is Robin and what does Robin do here? So Robin is application-centric converged infrastructure software. So that's a pretty loaded term. What does that mean? So first is Robin is a software-only solution, right? It's not a hardware appliance that you have to rack stack. So essentially, you can deploy Robin on any commodity hardware. The second aspect is the application centricity. So containers, by definition, are application-aware, right? I mean, they were designed to ease the deployment and management of apps. And so Robin is leveraging container technology to simplify application management, to improve your application performance, and also maximize your hardware utilization, right? So what does that mean? So with a platform like that, what can Robin really do for you? Well, number one, it can consolidate databases for you. It can consolidate your Hadoops, your big data apps. It can also let you run Oracle's, Elasticsearch, MongoDB, you name it. And you can run all of this on bare metal, right? So no performance penalties. Secondly, it can help you reduce your software licensing cost. So for example, if you're running Oracle, the Oracle licenses are per physical server. Essentially, you have to license all cores on the physical server. And now with Robin, you can run multiple Oracle containers and maximize the utilization of your infrastructure. So you contain the software licensing cost. The third is Robin provides an app-to-spindle quality of service guarantee, which means you can now deliver predictable application performance, even when you're consolidating more and more apps on fewer servers. And finally, we want to simplify the data management for end users. And that means the one-click deploy, clone, time travel, all those features. So let's dig a little deeper, right? So let's look at what Robin is really comprised of. So let's say you start with your commodity hardware, right? So this is stuff that you bring in as a customer. Now on top of this, you layer the Robin compute plane, right? This is a collection of software which will help you deploy, containers and manage them. Yeah. Second aspect is you deploy the Robin storage or data plane, which will essentially discover the disks that are part of your commodity hardware and format them for use. Now to stitch them together, Robin also has a fabric controller. Now, a lot of people misconstrue this to be just an orchestrator, but it's not the case, right? So the fabric controller in our case does two things. One is it provisions and manages the infrastructure, and number two, it will also do application orchestration. And once you have this, and you can also extend to the cloud if need be, right? So given the trends, hybrid cloud is a key requirement, and Robin completely supports that notion. So once you have this platform laid out, you can deploy multiple containers, and not just individual containers, but you can cluster them together to form applications, right? So that's the Robin platform in a nutshell. So we talked a lot about storage, and so let's dig a little deeper. So one of our goals behind designing Robin was to make infrastructure invisible. So as a user, as a consumer of this software, all you do is think about the application. So you deploy Cassandra cluster, Oracle databases, Hadoop clusters. You never worry about, how many containers do I need? Where is the storage coming from? What are the volumes? How are the volumes being provisioned? How is the network being configured? None of those details. It just happens, automatically for you. From a storage standpoint, we have built our storage platform from ground up. So it is designed for containers. So we haven't just taken our traditional storage and written a volume plugin and tried to showcase that as a container-aware storage. We have built this from the ground up, and it's a scale-out storage, which means you can independently scale the storage and compute as much as you like, and it delivers block storage. So, which means due to the scale-out factor, you can create you can create 100,000 plus volumes, and these get created, destroyed in seconds, in fact, milliseconds of time. The benefit of block storage is that now you can format it with any file system. So if you want ext4, you want XFS, or if you're deploying Oracle, you can leave it as raw blocks for ASMUs. So block storage and complete flexibility based on what the application requires. And then it provides what I like to call as enterprise-grade features, like storage placement, data protection, thin cloning, compression, eraser coding. I think these are table stakes. So if a storage platform does not provide this today, you're clearly missing this out. But again, remember, all of this is running on commodity hardware. So there is immense cost saving with just the storage-defined storage, software-defined storage. One of the marquee features of the product is app-to-spindle quality of service guarantee. So what that means is now what Robin can do, given the combination of a storage and containers, essentially we can control resources and enforce priorities at each layer. What are these layers? Compute. So again, we can control CPU memory at the container level. Network. So we can tag packets so that the QoS policy set up on your switch or router can be honored. And then at storage, we can control IOPS. So you can essentially set up a minimum which guarantees the amount of IOPS that are delivered for read and write, and you can set a max limit which will sort of put a cap so that other applications running on that infrastructure or on that storage are not impacted in case you have a runaway query or you're suffering through a DDoS attack. So both min and max give you good protection. Now, when we have such fine-grained control, we can do some interesting things with it. And I talked about with transient spikes in your workload. And this is where we introduce the notion of scale up, not just scale out. If you follow the animation, and essentially I have a cluster, 3-node cluster, which has some set of IOPS, being deployed, being configured for this app. And now with a simple switch of the slider, I can move those sliders to the right side, and I seamlessly add more resources to my cluster. So I give it more CPU, I can give it more memory, and I can dynamically change the read and write IOPS that are allocated to my cluster. Now this is huge, right? This is a really new paradigm. So what's happening here is, in the past, you had to, before you deploy a cluster, you had to go through this mathematical exercise of figuring out how many IOPS do I need, what is the performance that will be delivered by the configuration I've designed. Well, no more. What you can do is you just decide on how many nodes, how large you want your cluster to be, and you deploy it with a set of resources. And then as the application needs change, you can dynamically just scale up or give it resources, both compute level, storage level, and network level. You can give it these you can give it additional resources, and when you're done, let's say if it's indeed is a transient spike, you can even scale it down. So you can again move the sliders back to where they were and bring the cluster back to it, or you can leave it to where it was. So now the whole exercise of right-sizing your clusters is incredibly simplified, right? So enough slideware, maybe some time to see demos. But before I move on to demo, I wanted to draw the whole picture for you. So what you had in the past, so if you, without Robin, you were deploying clusters by, for every team per use case per SLA. And that meant you had a lot of servers and a lot of clusters which were not used 100% of the time. And that's because each application has a different load profile. So you have batch, analytical, you could have different types. And with Robin, essentially, now what you can do is you can seamlessly migrate these applications onto almost half the infrastructure that you need. And at the end, just because the workloads, the workload patterns, you may even have some additional space that you can use to run additional applications or additional capacity to run other apps like Solar or whatever, Spark or something that you need on. And that's where you can pack with Robin, you can pack more applications per machine. You can easily get 40 to 50% reduction in hardware, and in fact even more depending on the kind of load profile your applications generate. And you get all the benefits of rapid deployment and portability of containers. Okay, so all right, so let's see some demos. So I'll switch screens and I'll kick off my demo. So so this is a little involved screen. So I've gone the split browser route. So on the right side, what you see is the read IOPS and the write IOPS that are being generated by the application. On the left, you will see the Cassandra cluster. And then below my cluster, I have a terminal where I'll be running all kinds of workloads for this demo. So let's start with the first demo. This is, we are going to showcase controlling write IOPS. So what I do is I kick off a write workload. So I'm using Cassandra Stress, and essentially I'm writing 50,000 rows of, each row is about, I think, 16 columns here and 1 KB each. So it's a fairly decent load. And what you will see immediately is that you see on the graph down here, you see the application do about 10K IOPS, give or take. Now this could mean two things. One is the application just needs about 10K IOPS, or maybe the disks are limited. But it's neither in this case. What we have done is, using the Robin interface, we have constrained the write IOPS to about 10K. So I've limited the maximum IOPS given to my app to about 10K only. So let's fix this problem. Clearly, my application could use more. And so what I'm going to do is showcase the scale up ability. So I'm going to move this slider to the right side. And I'm essentially, uncapping the IOPS. And what you should see now is the IOPS suddenly jump up to all the way to about 30K or so. So that's what my application really needs. And as I said, this was a dynamic change. I didn't have to bounce the application or didn't have to make any changes to the application, right? So it all happens real time, dynamically, as you see it. Now let's look at another demo. This time we'll use read IOPS. Since we loaded some data, now we'll do some reads. And what's happening here is I have an application called IOHogger that's actually using up all the IOPS or is using all the capacity of my SSD drives. And so when I kick off my Cassandra Stress again, this time doing reads, you will start to see, so you'll see pretty soon that a little gray color starts to show up. There you go. So now Cassandra is, the load is increasing and it's starting to show up. And now you see the two applications competing for resources. And that's not desirable because I get very choppy, I get a very choppy output. So I don't like this kind of behavior. So what I'm going to do now is give some guaranteed IOPS to my Cassandra cluster. And this is very easy to do again. So I go back to my quality of service screen, and what I've done is I have changed the minimum read IOPS limit to 20K. And what this will ensure, now, so what we should see in the graph is now Cassandra gets a consistent 20K and my IOHogger essentially gets constrained, okay? So as I apply the changes, let's focus on the read IOPS screen, on the read IOPS graph, and then there you go. So you'll see Cassandra about, give or take, it's doing about 20K IOPS consistently. All right, so that's exactly what I wanted. Okay, but then I see the spike from IOHogger. Now this is undesirable. That's what I like. That's what I call noisy neighbor, which means IOHogger is quite opportunistic. If given a chance, it'll use up all the IOPS that are available by my disks. So I just want to contain this. I want to control IOHogger for the duration of my Cassandra Stress. And so what I've done is I have reduced the max limit of my IOHogger application to about 10K. And what you will see is immediately, as the changes get applied, immediately the IOPS for IOHogger have dropped down to 10K. And now my Cassandra workload has ended, but even after that, you don't see IOHogger opportunistically trying to consume more IOPS. It stays constrained to that limit. All right, so let's move on to a third demo in which we are going to scale up our CPUs. So in this case, we are going to focus on the terminal down there. And what I do is I kick off another read workload. But this time, what you see is that I have allocated only about 2 cores for my Cassandra cluster. So the first time I run my Cassandra Stress with read, it takes about 18 seconds to load 50,000 rows. And you can see that it was only able to do about 2,700 operations per second. Now, once again, I use the ability to do dynamically scale up, and so I give it 10 cores. So that's a lot of processing power considering I'm using about 500 threads for this Cassandra stress. And so this time, our expectation is that the test should complete much faster. And as we watch, there you go. So 4 seconds, and if you look at the ops per second rate, we did almost about 12K. So that's a huge jump. And that sort of concludes the first demo. So let's go back to our slides. All right, so bear with me as I switch back. Okay. So let me just summarize what we saw. Essentially, we talked about fine-grained quality of service control, all the way from application to spindle. This means you can control CPU, memory, and both read-write IOPS. And using this fine-grained control, what we were also able to do is introduce this new notion of scaling your clusters up and down, which is an incredibly powerful feature not available via any other platform. All right. So now let's move on and look at some of the other things the platform is capable of, and how we go about solving our other management problems. So we talked about deployment complexity. In Robin, deploying software is extremely easy. Essentially, you have this notion of an application catalog, which has a collection of bundles. So you can see Hortonworks, Kafka, Mongo, Cassandra, and there are many more that we support out of the box today. But all I do is, from a consumption perspective, I go as an end user, I go click on Cassandra, and what it does is opens a dialog for me. And it shows all possible inputs that are required to create Cassandra successfully, to create a full-blown Cassandra cluster. So if I just walk through the inputs, I can specify there are 2 roles. There is a seed role, and there is members. So typically, depending on whether you're doing single data center, single rack, or multi-rack, you will decide the number of seeds that you like. So you can provide the CPU memory settings for the seed container, and you can also set the values for the volumes that are needed. So in my example, we have at Robin, we use about 4 volumes for Cassandra, 1 for commit log and 3 for data. You can add more to say 1 for just application logs and etc. What you can also set is the IOPS settings for both read and write. And then a bunch of environment variables. Again, this is totally customizable. So for internally, we just specify the heap size and then the broadcast IP address and the listen address, so that when members and seeds are added, the cluster gets to form correctly. And the membered role is kind of similar. So again, CPU memory, volumes, etc. So very similar inputs with the additional environment variable for the address of the seeds. And this is where we have our own templating logic, where we have our own templating logic so that we can parse variables from a different container and use it at deployment time. So let's say you select a bundle, you fill in all the values, and then you click provision, and that's it. That's how easy it is to deploy. But what's happening, it's important to understand what's happening behind the scenes. So when you click, you enter values in the dialog. What's happening behind the scenes is containers, and this is where our Fabric controller comes into play. So this is where we are doing container placement, we are doing storage provisioning, we are provisioning all the volumes that have been demanded by the applications. We are setting up replication if that's what the application demands, data protection, etc. What we can also do is, in case of node failures, we can seamlessly move your containers around. And again, this is not just for stateless apps. This is also for your data apps. So for your Hadoops, for your Cassandra, for your Oracles, all these kind of data-heavy applications, we can seamlessly move the container over. All the storage part is automatically taken care of you. And the best part of all is the container retains its identity. So it has the same host name, same IP address, same MAC address. Everything is the same. So literally all you would see is a small blip, and within seconds, you will see the container come back. So your application is live. All right. So that's container failover migration. Now the benefit when you apply these kind of capabilities to Cassandra, essentially what you're doing is you're eliminating the whole concept of permanent failures. There are no permanent failures anymore to deal with. Isn't that amazing? And even for temporary failures, you're reducing the duration of the temporary failure to a few seconds. And just to clarify, there are two kind of variations to this. One is if the container dies due to an operator error or due to additional load on the container or something like that, we try to restart the container on the same host, provided the host is healthy and you have enough resources. But if the host itself is not available, let's say it's on fire or somebody unplugged it or there's some physical damage to it, then we seamlessly migrate that container to a different host completely. So there is some intelligence baked into the platform. All right. So one of our challenges was dealing with data itself, right? So backups, we said extremely manual per node, and then it consumes too much storage. So how do we deal with those? So let's look at an example here. So what I have here is a production cluster, and let's say we have been loading some log files into it. Now I get a request that a new application has to be onboarded, and consequently you want to test schema changes. And obviously it's not a good practice to test schema changes on the production cluster. So what you simply do is create a thin clone. Now what is a thin clone? Essentially it's a space efficient copy of the entire production cluster, which means only the changed blocks consume any storage, right? So think of it as a delta disk. Now these thin clones take seconds to create. When was the last time you created a Cassandra cluster, a clone within seconds, right? We let you do that. And with Robin's patent pending IO caging ability, we guarantee that the thin clone will have no impact on the production cluster, right? So we completely isolate the IOPS between the thin clone and the source and the production cluster here. Now, thin clones are typically good for short time spans. So, for cases where you want to do data recovery in the production cluster, or you want to test schema change and things like that, this is very valuable. So let's continue with our example. So what we do now is we've changed the schema. So we made some changes to a schema. Let's say we want to onboard an application that collects car sensor data, so an IoT-based application. Now it's important to note that the source moves on as usual. So the changes that you make to the thin clone have zero impact on the production cluster. So production you can keep on loading more data, taking snapshots, etc. Now once you have loaded all the data, you have run all the tests, you're happy with your schema changes, what you can do is you can now go and make the same changes to your production database. And you can start loading the new data. So now you're happy with the change, you have truly validated your changes, and now you don't need the thin clone anymore. And so simply you can click on delete and get rid of the thin clone. So that's the first use case. What you get with Robin's ability to take snapshots and do thin clones is you get data and schema versioning. So you can version your data and schema all at the same time. Remember, when you take a Cassandra snapshot, you only take a snapshot of the data, not the schema. With Robin snapshots, the entire state of the data of the database, including data and schema, gets captured. Right? So quite powerful feature there. Now let's look at another example. This is what we call as application time travel. So similar scenario, we have a production cluster and we are loading log files. Now someone comes in and says, hey, we want to do some analysis on the log files. And so we need the ability to mutate that data. And we also want to retain this cluster for a long time, let's say for a year or so. So in this case, you don't have to do a thin clone, you could do a thick clone. I'm trying to show you the different variations, but a thick clone essentially is again detached from source. but it takes the same amount of space as the production cluster. So if production is 1 terabyte, your clone is going to be 1 terabyte as well. And typically, you do want to keep these for a long period of time, right? So that's the sort of the key differentiator here, the lifespan of that cluster. Now you start making some mutations to the data, right? And once again, the source keeps moving on, as we have always said. The moment you take a clone, the clone and source have no relationship. And so we make some mutations. So I have modified the log files once, twice, and then I realize, oh, we made a change. We have a problem. There is either some data corruption, or maybe we ran a truncate table or something like that, and we lost too much data. So how do we recover? So typically, in the absence of Robin, you would go out there, you would stop the cluster, you would delete the old commit logs and data files, restore from backup, restart, and this has to be done per node, right? So it's again a time-consuming activity. But now, with Robin, all you do is essentially move that slider. With a simple swipe of a slider, you can move back in time and restore the state of the database to the desired state. So I've gotten rid of all the data loss or all the incorrect mutations that were made to the database, and I've recovered it. And that's, again, application time travel. With a simple, moving of a slider, you can recover a complete state of your database. So once again, enough slides. Let's see a demo. Okay, so in this case, we are looking at a production cluster. And the first demo that I will show you is of scale out. So we earlier saw scale up and down. The platform also supports the ability to add nodes. So here I have a simple 2-node cluster, 1 seed, 1 member. And what I want to do here is essentially add a few additional members. But don't believe the product. Let's run node tool status and see that we indeed have 2 nodes. So we can see that there are 2 nodes, and you can also match the IP addresses. So you can see it's 16.10, which is again 16.10 and 16.2. So in Robin, every container that gets provisioned gets its own IP address. And in this case, we are using Docker containers, but we could easily have used LXC containers or any other container format that you like. So let's first load some data, right? Because testing a scale out without that would be pointless. So I'm going to run, again, use Cassandra Stress and write about 100,000 rows to my 2-node cluster. And we'll kind of fast forward through this process because we don't want to watch all the output. So this takes about 23 seconds, and it successfully loaded all the rows that I wanted. And so if I run node tool status again on this key space, I should see that the data is evenly spread across the 2 nodes. So there you go, say about 49 and 50%. So that's good. That's what I wanted to see. Now we go to Robin and we choose to scale out. And what does a simple dialog comes up, and it asks you, how many nodes do you want to grow by? And so we chose 2. So I'm increasing my cluster size from 2 to 4. And what Robin also lets you do, tells you, is the estimated usage. And that's good to know because you're sharing resources across a Robin cluster, and so you should, we want to let you know what the impact of this scale out action is. So okay, so I like everything. I don't mind the estimated usage, and I click OK. So this takes again a few minutes because what's happening behind the scenes is that members are being added to the cluster one by one, which is what Cassandra demands. So we'll again fast forward this through this part a little bit. But within a few minutes now, both my nodes have been successfully added. So I'll close the dialog, and if I look at Robin, I can see that there are 4 containers, each again with its unique IP addresses. And if I run a node tool status, I should see 4 nodes. And I again see that the data is evenly distributed across all nodes. So that's good. That's so the first demo is successful. Okay, so in the second demo, we'll showcase the snapshot, clone, and time travel capabilities. So again, I have three terminals here on the three windows here. On the top right, where you see text scrolling, is where I'm running the production cluster. So it's a two-node cluster, one seed, one member. And as always, we'll use Cassandra Stress to load some data. So again, loading about 100,000 rows. And again, this takes a few seconds, and there. So about 100,000 rows have successfully been added. Now what we'll do is, this is a good state, or this is a good time to capture the state of the database, right? So in future, if we ever have a problem, we would like to revert to the state. And so what I'm doing is I'm creating a Robin snapshot. So here you have two options. One is to take a snapshot on demand. So this is a manual one, and for demo, that's what I'll be doing. But essentially, you can also set a recurring policy. So you can, if you see the other option, which is disabled here, is you can choose a schedule and say how many for for what period and for which days you want to take these snapshots. And you can also specify a retention policy. So you can keep maybe 10 snapshots for over the last 5 days, 10 per day or something like that. So anyway, let's create a snapshot and then call this initial load and create. So these snapshots are very quick. They literally take a matter of seconds here. And so there you go. So my first snapshot is ready, and now I'm ready to create a clone. So for this demo, we'll choose thin clones. Like I said, thin clones are extremely fast. So I give it a meaningful name, and again, there is an IP pool that has been registered. So unique IP addresses will be allocated to the containers in the clone. Once again, what's happening is we are cloning the volumes. We are creating new containers, and where we are mounting the storage and making sure the new cluster that comes up is healthy and running. So there you go. My clone is complete. I can see that it was cloned from my production DB02 and the first snapshot that I took. Again, one seed, one member, new IP addresses. So let's connect to our clone. So we're using Docker containers. So we use Docker exec and connect to that IP address. All right, so let's get a persistent connection. We run node2 status, and it should show us the two nodes that were created. And then you can see the data distribution is identical, so 48% and 51%, which is the 100K rows that we loaded. So once again, even for the clone, I want to capture this point in time. So essentially, if I, since I plan to make destructive changes to my clone, I want to capture a state that I would like to revert to. So now, let's validate that we indeed loaded the 100K rows, or the 100K rows that we loaded in the source on the production database have indeed been copied over. So I use SQL sh to run my query, and it says, all right, all the 100K rows are available. All right, so now let's make some destructive changes. This is where the interesting part begins. So I start by doing something very dramatic, which is drop the entire key space. All right, but let's not stop at that. Let's load additional data. So not only are we dropping the key space, we'll mutate it further by loading, say, 50,000 rows to the database. Once again, I'm using Cassandra Stress. And there you go. So we will now successfully load about 50,000 rows, and Cassandra Stress should confirm that for us. There you go. And there. So confirmed. So key space dropped, and if I query the same key space, since Cassandra Stress creates the key space 1 by default. And now what we are doing is a restore operation. So we went back to the known snapshot that we have captured, and then we say let's restore back to the point in time. So one thing that just flashed on the screen is restore requires a downtime, because essentially you're shutting down the container and remounting the volumes. And so what you noticed is that I got disconnected from the container. So we'll reconnect to the Docker container, and if I run the node tool status now, I should see that the the data distribution is back to what it was, so 48%, 51%. And if I query my database, essentially it should return the 100K rows as it was when I was cloned it. And there you go. So confirmed. All right. So let's go back to our slides here. And all right. So let's recap. So what we saw in this demo is, number one, the ability to add nodes. So we scaled out the cluster from 2 to 4 very easily from the Robin user interface. And we also verified that all the nodes were correctly added to the cluster, and the data again was, the bootstrapping kicked in, and the data was evenly distributed across everything. And then the second demo we saw was we started with a production database. We loaded some data, created a thin clone out of it, and then we did time travel. So essentially, we dropped the key space, loaded some new data into the database, and then with a simple click, we said restore, and we were able to go back in time and revert the state of the database to that desired point in time. All right, so let's see what we have done so far in this presentation, right? So we started with 4 management challenges, and we said we want to use containers for this. But clearly, during the course of the presentation, we realized containers by themselves are not enough, because they give you control over CPU memory. But what about storage IOPS? And so with Robin's platform, which includes your consolidated, which is a converged platform of compute plane, storage data plane, the fabric controller that does infrastructure management and app orchestration, networking, all of that together gives you a rich platform which can solve all your management challenges. So what we get with Robin is now you can provision clusters on demand of the desired size and with the desired performance profile that you have in mind with the QoS, the quality of service control. What you also get is high amount of consolidation, like inherent consolidation. And that's because only Robin can give you performance isolation across applications. And containers give you process isolation. Robin, along with its quality of service guarantee, can give you performance isolation. And that means you can run more application on fewer servers. So you get about 50% reduction in hardware. So that's the first challenge of consolidation. Second, in terms of cluster lifecycle, it is very easy to deploy clusters. We saw how easy it was to define the kind of application that you need in terms of the volumes, the CPU memory, the environment variables that you want to pass. So again, simple application catalog, one click, done. We saw that node failures are a thing of the past now, right? Because we have effectively eliminated the notion of permanent failures. You only have temporary failures, and that too, the temporary failures have been reduced down to a few seconds. Data management, we have fully automated the notion of snapshots, and these are Robin snapshots, not Cassandra snapshots. So Robin takes scheduled snapshots. You can do it manually. You can do it on a schedule. You can also take clones. You can do time travel. So complete control over the data. And once again, all the snapshots are being stored on Robin storage. So they're not using up the space that has been allocated for your data files. So, your capacity planning exercises are still very relevant, and they'll still stay true during the lifetime of that cluster. And finally, we all know about scale out, or the ability to add nodes, but now we have introduced this new notion of scaling up and down, which means you can dynamically resize the resources that have been allocated, both compute and storage, and you can make these changes dynamically, and an applications will benefit from them. All right. So there, database management has been made simple. Now, in this webinar, we talked exclusively about databases, but this applies, the Robin platform can be used for everything: stateless, stateful, data apps, enterprise apps. But of course, our primary focus initially has been on stateful apps, data apps. So to summarize sort of the business benefits that you gain with a platform like Robin, number one, we are helping you reduce CapEx. So we are reducing your hardware footprint while retaining bare metal-like performance and delivering guaranteed application performance. Right? Number two is we are improving productivity. So your end users don't have to, keep filing tickets or call your IT admins or DBAs, database admins, for simple changes like deployment of clusters and for data operations. Now, you can now again give each team their own cluster. They can provision it by themselves. They can take snapshots, take backups, do time travel, clone, all by themselves. And your DBAs can focus on, key aspects of managing your infrastructure. And finally, you're reducing the OpEx. Just by the fact that you have offloaded the whole deployment activity to the end user, your DBAs now are free to focus more on infrastructure uptime or application uptime or performance tuning and other important tasks. So with that, I kind of conclude my my presentations. If you need more information, well, you can reach out to us over our Twitter account. You can email us. You can visit our website at www.robinsystems.com. And you can also look at our blogs. We have interesting blogs going out almost every week. And interestingly, we will also be at Cassandra Summit. So if you want to see more demos, live demos, you can either email us and schedule it, or you can stop by our Cassandra booth, and we'll also be at Oracle Open World to showcase our platform for managing Oracle databases. So I do see some questions here. So I'm going to leave the slide up, and I'm going to scan through the questions and see if I can answer some of these. So yeah, so the first, okay, so somebody caught on to me saying Oracle a bunch of times. And so the first question here is, can you really run Oracle on Docker, and is it supported? So the answer is, everyone thinks about Docker when you say the word container, but there are multiple container formats, and so what Oracle supports is the LXC, or the native Linux container format. And so the Oracle database can run on LXC containers, and that's what we use on our Robin platform. But for other Oracle products like WebLogic, Coherence, and other things, they are supported on the Docker container format. And once again, you can run those on Docker as well. Okay, so the next question that I see here is, I'm just looking at the clock as well. Okay, so we can maybe do one more question here. So the other question that I see is, let's see here. Okay, can you automate the up-down scaling based on load? So that's an interesting question. Yes, you can. And what we do is, so today what you saw was the Robin user interface, but we also have a command line interface, and we have REST APIs. So essentially, based on the application load profile, you can call any of our interfaces or APIs and dynamically add, remove resources as you deem fit for your applications. All right, so hopefully I answered that question for you. And I think it's 11 o'clock, so we are out of time. But what we'll do is we'll follow up and answer all your questions. So keep them coming. Send it to us via email or reach out to us over Twitter. For the questions we haven't answered on the platform, today, we'll email back to you or we'll publish a blog with our answer. So thank you very much for joining. I hope you're as excited as I am about the Robin platform and what we can do for your databases, big data apps, and in the context of this session for your Cassandra clusters. And hopefully you would want to reach out to us and learn more about it. So thank you again for joining us, and take care and have a good rest of the day. Bye.